And for example 1, we've got a revenue function. That's 9x. So that's the revenue. So what this means is we're selling something. Let's say we're selling Frisbees. So if we sell 5 Frisbees, then we're going to take in $45. Or if we sell 7 Frisbees, then we're going to take in $63. So this is how much money you take in. It's the revenue. Okay, and then the cost function is x cubed minus 6x squared plus 15x. We've had a cost function before. It's been a while though. So if we plug 5 into this will tell us how much it costs to make the 5 Frisbees total. Or if we plug a 6 into this, it'll tell us how much it costs to make 6 Frisbees. So this is how much money we take in, and this is how much money we spend in our business. All right, so then the question is find the production level. That will maximize profit. And find the maximum profit. Find the production level that will maximize profit, and also find the maximum profit. All right, so if we're going to find the maximum profit, what function do we need? Profit function, right? If we're going to find the maximum profit, we need a formula for profit. So we're going to call that P of X, capital P for profit. And the way you figure out profit is you have to take how much money you take in minus how much money you spent. So that's the revenue minus the cost. So revenue represents how much money you took in, and cost represents how much money you spent. So if you take the money you took in minus the money you spent, then that shows you how much you have left over for your profit. Okay, so the profit function in this case is just 9x minus this cost function. So be careful with the parentheses. You got to subtract the whole thing. So that would be an easy mistake to make, to forget to distribute the negative. So then if we distribute the negative, it'll be negative x cubed plus 6x squared minus 15x. And then you can collect like terms. So well actually they're, oh yeah, the 9 and the 15. So negative x cubed plus 6x squared minus 6x. There's my profit function. Okay, so all that so far was just finding the function for profit. But then the question's asking for the maximum profit. So how do you find the maximum of something? Take the derivative, set equal to 0 and undefined, right? That's a procedure for maximizing something. So P prime is negative 3x squared plus 12x minus 6. So we need to set that equal to 0, and also equal to undefined. Derivative's never undefined, right? In this case, because it's just a polynomial. Okay, so this is quadratic, so we could try to factor it, but it turns out it doesn't factor. So how do you solve if it doesn't factor? It's a quadratic formula. So that's what we got to do on this one. Okay, so that's the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So it might be a long time since you used that quadratic formula, but that's how it works out. So let's see, that's negative 12 plus or minus the square root. 4 times 6 is 24, times 3 is 72. This is 144 minus 72 all over negative 6. So that's negative 12 plus or minus the square root of 72 all over negative 6. The 72 is 36 times 2. So that's negative 12 plus or minus 6 root 2 over 6. So I just split up the 72 into 36 times 2, and the square root of 36 is 6. So then I can divide everything by negative 6, so that's 2 plus or minus root 2. Everybody doing okay? I know it's been a long time since you maybe did this kind of stuff, so. Okay, so now we got our critical values. So we have to put those on a number line. So we've got 2 minus root 2 and 2 plus root 2. So now we're going to test our intervals. So I plugged a half into p prime, and I got negative 0.75. So I'm just looking at what I did last year, but right here's my derivative, right? So I just plugged a half into that, and it came out to negative 0.75. So that means this is negative. And then I plugged 2 in for in between here. That came out to 6. So that's positive. Then I plugged 4 in, and that came out to negative 6. So that's negative. Yes.
Why do you stop it on the line?
Because you can't make negative numbers of frisbees. So in this problem, before you got here, the x represents how many frisbees we're going to make. And so the r of x function is the revenue function. So it's how much money we take in when we sell that many. And then the c of x function is the cost function. And it's how much it's going to cost us to make all those. Good. All right, so there's that. And what's going on at this point? What did we just prove is happening at 2 minus radical 2? Sorry, what was that? It's a local minimum, right? Because the slope is switching from negative to positive. Okay, and then at the other point, there's a local max, right? The problem is we're looking for the absolute max. So we have to think about this a little bit carefully to know what's going on. Okay, so there's two possible scenarios. We know, well, let's write this down. We know there is a local max at x equals 2 plus root 2. Based on this sign chart, that tells us the local max. Okay, so what could be happening is maybe the graph starts out pretty high, and then it goes down and up and down. So maybe it goes down and then up and then down like this. If that's the scenario, then this is not the absolute max. This is the absolute max. But it's also possible that the graph doesn't start out quite as high and goes down and up and down. And in that case, then the absolute max would be the same as the local max. So based on our chart, we've just eliminated it to one of these two scenarios. So how can we figure out which scenario it is? Yeah. Yeah, if you plug 0 in and get this value, and then plug 2 plus root 2 in and get this value, then you'll know which one's higher. Okay, so we're going to calculate P of 0, the profit if we don't make any frisbees, and then also P of 2 plus root 2 to see which one wins. Okay, so P of 0, that's back to the original. So that comes out to 0. And then P of 2 plus root 2, I don't have that down, so I better figure it out. So I'm plugging into the original, right? The profit function was negative x cubed. So I'm getting 9.6 0.57. So that means that it's not this situation, right? So this is out. This is higher than this. And so this is the absolute max. Okay, so the absolute max occurs at x equals 2 plus root 2, which doesn't make a lot of sense here because x represents how many frisbees, right? So let's get a decimal for this. It's 3.414. And my memory is starting to get jogged a little bit. I didn't mention at the beginning, x is supposed to represent thousands of frisbees. So go back to the original problem and write that down. X represents thousands of frisbees. So that means I'm going to make 3,414 frisbees. So we should make and sell 3,414 frisbees to get our maximum profit. And then this is also in thousands of dollars. So that means when we do that, our profit is going to be $9,657. So if all these numbers are correct, and I can make 3,000 frisbees in a month, I'm going to check tonight and see if this is all correct. But if this is true, I won't be back tomorrow. I'll just start this business instead. It won't be as much fun, but at least it's frisbees, right? Not as fun as math, but almost. You're all thinking, I hope it's going to work out. It would be nice if he wasn't back. Actually, I have all the lectures from here on out on tape, so because I started taping about this time last year. So I don't need to come back. I can just have you. All right, here's example 2. So in example 2, we're going to have another cost function, c of x. Well, it's the same cost function as we had in part A, x cubed minus 6x squared plus 15x. And for part A, we're going to find the average rate of change of the cost on the interval 1, 3. All right, so how do you calculate average rate of change? f of b minus f of a all over b minus a, right? So in this case, it's the average rate of change of the cost, so it's going to be c of b minus c of a all over b minus a. So I plugged 3 into here, and it comes out to 18. And I plugged 1 into there, and it comes out to 10. Then we got 3 minus 1 on the bottom. Then 18 minus 10 is 8. 3 minus 1 is 2. So that means on average it's going to cost $4 per Frisbee to make between 1 and 3 Frisbees. That's how much extra it's going to cost. Like it costs $18 to make 3. It costs $10 to make 1. So it costs an extra $8. And then that was an extra 2 Frisbees. So it's an extra $4 per Frisbee from 1 to 3 on average. Maybe it was $5 for Frisbee number 2 and only $3 for Frisbee number 4. But on average, it was $4 per Frisbee from 1 to 3. Okay, then question B says, find the average cost when x is 2. So this is a little bit different. This is not average rate of change. It's just plain average. Okay, so in order to figure out the average cost when x is 2, I'm going to figure out how much it costs to make 2. So I'll plug 2 into the cost function. And that comes out to 14. So this means it costs $14 to make 2 Frisbees. So then on average, if you divide that by 2, that'll tell you on average it costs $7 per Frisbee. To make 2. So there's a very subtle difference between part A and part B. In part A, we're finding on average how much extra it costs to make from 1 to 3 Frisbees. Like we were going to make 1, and we're trying to decide if we're going to make 3. And so we know that it's going to cost us an extra $4 per Frisbee from 1 to 3. But here, it just costs us an average of $7 per Frisbee to make the first 2. So this is average as opposed to average rate of change. Okay, then part C is find the minimum average cost. All right, if we're going to find the minimum of something, we need the formula for it. So for example 1, we wanted the maximum profit, so we wanted a formula for profit. So in this question, we want the minimum average cost, so we need a formula for average cost. So we've got to figure out average cost, whatever that is. But we've already figured out average cost here, right? the way you figure out average cost is you take the total cost divided by how many you made. So the total cost is, well, before we do that, let's just write it down. You take the total cost divided by how many you made to figure out average cost. The formula for the total cost is right here, x cubed minus 6x squared plus 15x. So to figure out average cost, we have to just take that and divide it by x. So x cubed minus 6x squared plus 15x divided by x, that's the average cost function. So that'll distribute. It's x squared minus 6x plus 15. Just divided each of these by x. Okay, so now I've got my average cost function. So how do I find the minimum average cost? Take the derivative, set it equal to 0 and undefined, right? Anytime you have a function that you're trying to minimize or maximize, that's the procedure. Okay, so I take the derivative of average cost, and that's 2x minus 6. So we'll just make a quick note, it's never undefined. Just so we don't forget to check that. And then it equals 0 when x is 3. Hey.
I just have a real quick question.
Okay.
Your computer, did you have any issues this morning when you logged
No,
in?
it's good this morning.
Okay, good.
So I moved the desk, and I think it just jiggled that connection, and
Okay.
I couldn't figure out how to get it
Fair enough.
back.
We were in here yesterday
Yeah.
where that figured itself out. I just wanted to make sure everything was
Yeah,
good to go.
thank you so much for stopping by. Yeah.
You're very welcome.
Okay, so we got to check and make sure this is a min, right? So 3, it's our only answer. So we're banking on the fact that this is probably a min, right? But we do have to check anyway. Because I don't think there's going to be a question that has no answer. But it's good practice to check and make sure that it's a min. All right, so we're going to plug 1 into the average cost. I feel like when somebody walks in, I should warn them not to say any cuss words or anything. You're on tape. You guys are warned, but anyway. I didn't think he was going to yell at me, but you never know, you know. So you plug 1 into the average cost derivative, and that's 2 times 1 minus 6. So that's negative 4. So that's negative. And then you plug 4 into the average cost. So that's 2. So that's positive. So that's good that this is a min, right? And since it's the only critical value, it's the absolute min, because the graph is always going down and then always going up. So x equals 3 is the absolute min. Well, it's where the min occurs. So the minimum average cost occurs at x equals 3. And then if I figure out, if I plug 3 into my average cost, then that'll tell me the minimum average cost. And that comes out to 6. I just got this 6 by plugging 3 into here. So the smallest average cost is $6 per Frisbee. Everybody's doing okay? Okay, there's just one more thing I want to mention. It's not an actual problem, it's just a comment. Should help you on one of the problems that you have to do for homework. So it's not an actual problem, but let's say you have an S of t function. What does S of t stand for? Position, right? And let's say the question says, find the maximum velocity. So the problem is we don't even have a velocity function, right? But how can we get it? It's just the derivative of this, right? So you take the derivative of position, and that gives you velocity, right? Okay, so now we have a velocity function. How are we going to find the maximum velocity? You got to take the derivative of velocity and set it equal to 0 and undefined, right? So you see the issue? Some people would take the derivative of position and set it equal to 0 and undefined. But that would find the maximum position. So you're going to end up taking two derivatives when you solve this type of a question.